Today we're going to start with a tutorial. First let me introduce, I work for a company in Seattle called Monster Costume. I do contracts for game companies under Monster Costume, that is, working with a nice team. We made the recent app of the week, Bartleby's Book of Buttons Volume 2. Today I am going to show you how to do Tic Tac Toe. So let us start from the beginning. So I created, well, almost the beginning, I created an app called Tic Tac Toe Tutorial. It's going to make the generic program. This will be red in yours until you hit build and run. Before you do that, you might want to change this to the iPhone simulator, because we're going to do an iPhone. You can do it on the iPad too, but it'll be a lot easier on the iPhone because it's not going to be very big. After that, hit build and run. And that just gets it so that this is no longer a red tic-tac-toe tutorial under targets. So nice gray screen, just like usual. Unlike other tutorials, I'm going to skip straight into coding it. I'm not really going to go over the background. So Apple Q will quit that, and let's go into the view controller. We're going to uncomment view did load, and we're going to set up the grid. We can create a function just to keep the code clean called setUpGrid or setUpGrid, and it helps to already create this function. So it's easier for autocomplete to tell how to finish it. If you triple click a line, you get the whole line. Go into the header file, give some space, Control V, save it, otherwise it won't autocomplete it later. Okay, so view did load gets called, it's going to set up the grid. So we're going to create a 300 by 300 view container that'll hold all of the views. I'm not using zibs this time, as you can tell. And that's because I want whoever's watching this to underline what's going on. So, view alloc, init with frame, and we're just gonna create a CG rect, and we're gonna make the math easy. Start at 0, 0, give it 300 width, 300 height. We could right now have done the where's the very center and place that, but there's another way you can do that. So first we need to add it as a subview to the view controller's view, which is that gray screen you saw earlier. So self.view, add subview, grid. Now we alloc and init it so the retained count went up 1. Let's make it go down because adding as a subview, the views retain their subviews, so it has a retained count of 2. So let's release control of it. Now we're going to do that trick where it puts it in the center. So grid.center equals self.view.center. That's the center of the screen. Assuming you're not going to rotate it, that is. Okay, I'm just going to move my window up a tad. Okay, so I'll let you see what I did. Forgot that this was a fixed area, but I can see what you're able to see, so I'll try to remember that more in the future. So we now have a grid. We should give it a background color. Grid.background color equals UI color green color. Nice little convenience function. And every time you make a change that's visible, hit Command R and hit Enter to save it. It'll ask you if you want to save if you haven't saved it yet. And it's nice to see what you did. So it's in the center of the screen, where it should be. It appears to be a little bit lower. And it's green. So let's not worry about that placement for now. You can always tweak it and NSLog exactly what's showing up, and you'll eventually figure out what it's doing. For now we need to put a grid of views in the middle of them and make it so that they can be responded to. And this is going to be tic-tac-toe. And since I don't have X's and O's ready as images, I'm actually just coding this so that you can code along. We're going to use colors instead, and that's going to be after the user taps the grid. So, long story short, we need to make 9 boxes, and they need to fill up a 3x3 grid. So, what I'm about to do is very common among any game that uses tiles. And y equals 0, y is less than 3, which is really the grid height. Sometimes you'll dynamically say y is less than grid height. Okay, y increases by 1. Well, there's an x and a y in grids. And x is less than 3, x plus plus. You should probably assign it. Okay. So that's going to loop 3 by 3 times, so 9 times. Which means we need to use this to move around a rectangle and shove views wherever the rectangle is. Now, for the sake of not initializing things more than once, let's put the rect that we're going to use, let's just use it something generic, rect. Okay, so CG rect is declared outside of the loops. New ISO, or rather the C as of 99, I believe, lets you declare things inside of loops, but I don't like doing that. Anyway, we notice how it's 0, 0, 300, 300 up here. It's going to move, obviously, 100 spaces to the right every time. Then every time it changes to the next row, it's going 100 down and back to 0, 0. Well, lucky for us, this y value changes once every 3 times because the x value loops 3 times before the y changes. So essentially we're going to let it do this, and then it's going to create another, and then another. We just have to match that up to the visuals. So, while x equals 0, we need rect to equal CG rect make. We use those changing values. So this is going to be the x times 100 right there. And then this is going to be y times 100. And if we follow this mathematically, we'll see what's going on. Width is going to be 100, height's going to be 100. We know this because the grid is 300 by 300, but a safer way to do this is to say, grid dot frame dot size dot height for the y, or rather the height, divided by 3, and this is going to be grid dot frame dot size dot width divided by 3. And that also gets calculated every single time, and it's always going to be the same number, so even that is an efficiency that you can actually take out, turn into a variable, and put up here with rect. So you'd say float grid width equals, and then this. I'm not going to bother with too many efficiencies of this, just because I want to get through the Tic Tac Toe. So I'll only do this particular one. But there, now your processor's not going to calculate that every single time. Alright, so we have the rectangle. And what are we going to do? Very similar to up here. So we're going to dynamically give it a frame. So, I'll want to create a view, but it looks like I'm going to do some other things to it, like add target, like add functions to it. So I might actually want to create a pointer that will point to it afterwards. So UI view v, there, that'll point to any view. Sorry, there you go. So I just added that under the rect. Okay, so v equals UI view outlook. Can you guess what I'm going to write other than init with frame? I already have a rect ready. Ha, I messed up. I'm going to use the frame that we just created right above it. Init with frame rect. Alright. Should we give it a background color so we know that we're doing something? Why not? Background color equals UI color, red color. Am I forgetting to add it as a subview? Yes, let's do that. So grid, add subview, V. Don't need to retain it anymore. So subview's retaining it. Okay, that looks like a good enough change to save all and let it run. So let's see what it does. Ooh, the whole thing's red, which means there's 3 views in every row and column, and they're all covering it up. So perfect, the size matches. Normally you'd offset it just a little bit and ensure that. We can actually do that right now. So you don't have to type in this code. I'm going to use a trick you're actually going to be able to use when making grids later. So we're going to use the conditional operator, or actually, no, let's not use the conditional, let's make it if. It does the same thing, but this one's easier to read. So if arc4random, this just gets a random number, modulus 2, grabs the remainder, is equal to 0. We're going to say the background color is not red, so let's make it green again. It won't really matter because it's going to contrast. Else, do the thing that I'm already doing. So triple click, and paste. So this is completely random. As you can see, they're relatively evenly spaced. What I actually wanted to do is every other one, but that would take a little more calculations. I wasn't thinking. So we gave them a background color. I obviously just now took away that background color. We already verified it's working. Since we verified it's working, we don't need it. Next, we are going to go over input. So I'll actually make that a separate video.